When we simplify this quadratic formula, our next line is t equals negative 100 plus or minus 10,000 plus 20 divided by negative 10. So t equals negative 100 plus or minus 10,020 divided by negative 10. So t is equal to either negative 100 plus the square root of 10,020 divided by negative 10, or t is equal to negative 100 minus the square root of 10,020 divided by negative 10. This one, t is approximately negative 0.01. In other words, our zero time right here. For this one, t is approximately 20.01 seconds. We can't have negative time, so we know it's not going to work. So the flare was in the air from the time it was fired, t equals 0, until the time it hits the ground, at approximately 20 seconds. What was the height of the flare when it was fired? When the flare is fired, the time is 0. We can calculate the height, h, when t equals 0. We substitute 0 in for all the t's. So h equals negative 5 times 0 squared plus 100 times 0 plus 1. So h equals 0 plus 0 plus 1. So our h before it was fired, or when the flare was fired, was 1 meter. Another question we can ask is how long was the flare above 376 meters? We can calculate the time values when the height is 376 meters. So we'll have 2 points. We don't know when those occurred. But we can substitute 376 in for our h. We'll then move everything to the right side. And then we get this. A quadratic expression in standard form. Negative 5t squared plus 100t minus 375. So, we'll factor negative 5 out, which gives us negative 5 times t squared minus 20t plus 75. And then we can factor this trinomial, and that's t minus 5 times t minus 15. T minus 5 equals 0, and t minus 15 equals 0. To make this statement true, t would be 5, and to make the second one true, t would be 15. The flare stays above 376 meters from 5 seconds to 15 seconds, so for 10 seconds. Example 4. On a sunny day, the daily profit, P in dollars, of a popcorn vendor is modeled by a given equation, where D is the price of a bag of popcorn in dollars. So P is the profit is equal to minus 60 times D minus 4 squared plus 120. What should the price be to maximize the daily profit? What is the maximum daily profit? Let's look at our vertex form. Our vertex is at 4, 120. The parabola is facing down, therefore at the vertex there is a maximum for 120. This is the price, D. And this is the most amount of money that can be made, the profit, P. So the price should be $4, because at $4, your profit is maximized at a $120. Example 5. The area of a vegetable garden is 120 meters squared. Find the dimensions of the garden if the length is 8 meters longer than double the width. Let W represent the width of the garden in meters. Remember, the length is 8 meters longer than double the width. Then the length can be represented as 2 times W, or twice the width, double the width, plus 8, 8 meters longer than double the width. So write an equation for the area. Area is length times width. So area is W, the width, times 2W plus 8, which is the length. We know that the area is 120 meters squared. So 120 is equal to W times 2W plus 8. We'll now solve to find the width of the garden. 120 is equal to 2W squared plus 8W. What we've done here is multiplied W times 2W and by 8 to give us this. We'll then move the 120 to the other side. Now we have a quadratic expression in standard form. We'll factor out a 2. So 2 times W squared plus 4W minus 60. This can be factored into 2 times W plus 10 times W plus minus 6. So W plus 10 is equal to 0. Or W minus 6 is equal to 0. So for this first one, W will equal minus 10. For the second one, W equals 6. The width cannot be a negative value. How can we have a negative width? So the only possibility is that the width is 6 meters. If the width is 6 meters, the length is equal to 2 times 6 plus 8, which is 20. So the dimensions of the garden are 6 meters by 20 meters.